over 9 times by x to the 9 over 4 plus this constant c. Yes, you're right, okay? So I'll just rewrite this, okay, as, okay, so I'll just write down the answer, okay. So this is x 5 over 4 dx, right? By using that rule, right? So x to the nth power dx equals n plus 1 or 1 plus n, whatever, x n plus 1 or 1 plus n, whatever, and then plus constant c. So this will give us 1 over 1 plus 5 over 4 x 1 plus 5 over 4, and then plus constant c because it is an indefinite integral, right? And then we can simplify this fraction, which is 1 over 9 over 4, flip 4 out of 9, x to the what? 9 over 4 plus constant c. Did you, everybody clear about this question, right? Okay, good. Question B. Find the antiderivative for x squared and 1 over x squared plus 1. So what will be the antiderivative? 1/3 x to the cube plus x plus what? Inverse tangent, okay, what arctangent, okay? Inverse tangent of x and then plus what? Constant c, done, right? Now let's look at this question C, okay? Integral of 2 plus tangent c squared d theta. Okay, for 2, we know the antiderivative is 2 times theta, right? Theta is a variable. However, for tangent theta square, do you have a direct antiderivative for tangent theta square?
No, so we no.
Yes. So we can rewrite it as, okay, sin of theta square over what? Cosine theta square, right? And then d theta.
Then you can rewrite the cosine as 1 over secant squared, and you get the derivative of that, because we have the antiderivative of that.
Okay, the thing is, if we want to rewrite the cosine theta by 1 over cosine by secant, right?
Yeah.
So we still have a sin theta square there.
Yeah.
So sin times secant theta square, what is antiderivative for this?
No, I was saying we keep them separate for right now because the
How can you keep it separate? It is multiplication.
Sine over, well, I mean, I guess it's not efficient, but you can solve it that way.
No. With 1 over cosine theta square, yes, we can rewrite it as secant theta square. And the secant theta square antiderivative is tangent, right? Tangent theta.
Yeah.
However, we still have a sin theta square multiplied by the secant theta square. We're not able to separate them. We're looking for this whole thing's antiderivative. So, no. However, just like you said, okay, let's rewrite something, okay? Well, here, I'm going to rewrite the sin theta square by what? By 1 minus cosine theta square. Why? Because we have a cosine theta square on the bottom. This is a key for the question, okay? Sin theta square can be written by 1 minus cosine theta square. Why? Because of this identity. I believe everybody knows this, okay? Sin theta square plus cosine theta square equals 1, right? So sin theta square equals 1 minus cosine theta square, right? Now we have 1 minus cosine theta square over cosine theta square. Let's what? Split. 1 plus 1 over cosine theta square. This gives us what? Secant theta square. I just write it directly, okay? 1 over cosine theta square equals secant theta square. And then minus what? What's cosine theta square over cosine theta square? D theta. Right, guys? So 2 minus 1 actually is what? 1, okay? So have a 1 plus secant theta square d theta. For secant theta square, we know the antiderivative is what? Tangent, right? So once antiderivative is theta, secant theta antiderivative is tangent theta, and then plus what? Don't forget to add a c. You may ask, oh, you will add a c. When will we add the c? Until the what? Integral sign is gone. Okay. If we're having the integral sign symbol, do we have c? No. So in the last step, we have no integral sign anymore. Every term has its antiderivative. Then we add the constant c eventually. Okay. You guys, that's good? Okay, so if you know how to do this problem, I hope that will help you to do, the C on the next day, okay? So let's do these questions in order, okay? So question A, what is the answer for question A? Do you have the plus C for definite integral?
No.
No. Definite integral, you see, the result will be a number, which is 55/63. Yes, you got it right, okay? And then for definite integral, the answer will be what? A function of the variable plus a constant C, right? You see? It's a function of x plus C. It's a function of x plus C. Definite integral. It's not a number. Eventually, the result is not a number. It's a family of functions, okay? However, for definite integral, eventually answer will be a fixed number, okay? So let's look at this question. Yes, you got it right already, okay? So this is x times by x to the 1/3, which is x to the 4/3. X times by x to the 1/4, x to the 5/4 dx, right? And then we use that rule, right? And the derivative will be 1/1 plus 4/3 x to the 1 plus 4/3 plus 1/1 plus 5/4 x 1 plus 5/4. This is antiderivative, and then we will evaluate from what? 0 to 1. Did you? Okay. And then this gives us 3/7 x to the 7/3 plus 4/9 x to the 9/4, 0 to 1, okay? And then it will give us, this is a capital F, okay? This is a capital F of x, okay? So you value the capital F at 1, replace every x by 1, it gives us the 3/7, 1 to the 7/3 is still 1, plus 4/9 times 1, right? And then minus 1. When we replace x by 0, we'll get what? Only 0, right? So 0 plus 0. Okay. So eventually we add up these two fractions. 55/63. Everybody agree with this result? Okay. All right. Question B. What is the result for question B? What do you get?
We got stuck.
You got stuck?
Yeah. So we have x squared over 4.
Okay, so x over 2, right? So antiderivative should be 1/2 times by x squared over 2, right? Which is x squared over 4. Very good. I cannot use an integral sign because this is antiderivative, right? And then minus what? 2 times by 2 over 1. What is antiderivative for 1 over x? Check the table. 1 over x antiderivative is ln absolute value of x. And I have 2 of them, right? Minus 2 times by ln absolute value of x. This is capital F. Did you get this step correct? See? X over 2 antiderivative is x squared over 4 minus 2 times by ln of absolute value of x. Got it, right? And then we evaluate this capital F from what? 1 to 2 because given limits are from 1 to 2, right? So we should have, this is x squared over 4, right? So we replace x by 2. I will say 2 squared over 4 minus 2 times by ln absolute value of 2 is 2, right? Minus, x equals 1, 1 squared over 4 minus 2 times by ln of what? 1, right? X squared over 4, minus 2 times ln x, right? And then 2 squared is 4, right? 4 over 4 is what? 1. 1 minus 2 ln 2, this is a constant ln 2, okay, 2 times ln 2 is a constant, okay? And then minus what? 1/4. What is 2 times ln 1? What is ln 1?
0.
Yes, it's 0, right? So eventually answer is 1 minus 2 ln 2 minus 1/4. So answer has to be 3 over 4 minus 2 times by what? ln 2. Done. do you want to give it a try for question C? I'll give you 2 minutes to give it a try. Because it's very similar to the previous question. 1 plus cosine theta square over cosine theta square. And it's already giving you the two terms, right? 1 plus cosine theta square. What you're going to do is to split this whole fraction into two fractions, right? Into two terms. What?
5 pi over 4.
5 pi over 4? Very close. What's tangent to pi over 4? It is 1, right?
Yeah.
But can we add 1 by pi over 4? No. So answer is 1 plus pi over 4. Right? Okay, now I'm going to show you. Okay. So 0 to pi over 4, very good, you guys got it. Okay, 1 over cosine theta square plus, what's cosine theta over cosine theta? 1 d theta. And then this is what? 0 to pi over 4 secant theta square plus 1. Now let's find under derivative tangent theta plus theta 0 to pi over 4, right? And then tangent pi over 4 plus pi over 4 minus tangent of 0 plus 0, right? So, what is tangent pi over 4? 1 plus pi over 4, and then this gives us what? 0. Can we combine these two?
No, I have no idea what I did.
If we have a pi plus pi over 4, that's 5 pi over 4.
Right.
But this one is just the 1, okay? So answer is 1 plus pi over 4. Okay?
I got that, but I don't know why I said